Hello everyone, today I am going to explain the design and Verilog implementation of a fundamental digital circuit, the 4:1 multiplexer. A multiplexer is a combination circuit which means its output depends only on its current inputs with no memory of past inputs. Think of it as a digital selector switch. Specifically, a 4:1 MUX has 4 input lines. We can call them D0, D1, D2, D3. Two select lines S1 and S0 and one output line Y. Now going to the block diagram. This is a block diagram of our 4:1 multiplexer. You can see the four input lines as mentioned earlier D0, D1, D2 and D3 and the two select lines S1 and S0 and the single output line Y. The block itself is like a black box that performs a selection function. The select lines S1 and S2, S0 determine which of the four inputs get connected to Y. Now going to the truth table. The truth table lists all possible combinations of the select lines and shows exactly what the output Y will be for each combination. When S1 equal to 0 and S0 equal to 0, the output Y is equal to A or D0. When S1 equal to 0 and S0 equal to 1, the output Y is equal to input B, D1. When S1 equal to 1 and S0 equal to 0, Y equals C, D2. And finally, when S1 equal to 1 and S0 equal to 1, Y equals D3, that is D. This table is the complete behavioral description of our circuit. Now we will go through the circuit diagram. Now the logic gate implementation. It uses AND gate to check if the select lines match a specific input condition, NOT gates to invert the select signals, and a final OR gate to combine all possibilities and ensure only one input passes through to the output at any time. For example, the path for D3 is only enabled when both S1 and S0 are high. Now we will go ahead with the Verilog design code. As we can see the design code here. The input signals are the four data lines A, B, C, D. The select line is declared as input 1 down to 0 select. This is a 2-bit bus where select 1 is the most significant bit S1 and select 0 is the least significant bit S0. The output is a single bit called out. If both S1 and S0 are 1, output D. If S1 is 1 and S0 is 0, output C. If S1 is 0 and S0 is 1, output B. Else output A when both the bits are 0. Now Verilog test bench code. It's called 4 into 1 MUX TV. It declares regular variables for the inputs to the design under the test, which are A, B, C, D, and select. It declares a wire called out to connect to the output of DUT. It initiates our MUX 4 into 1 module, connecting the test bench registers and wires to its ports. This is the DUT design under test. Inside the initial block, we define the test sequence. Dump file tells the simulator to save the simulation data. Dump vars specifies which variables to save. One means all variables in the current scope. The second initial block applies the test patterns. Finally, finish ends the simulation. When we run this, the simulator generates a waveform file that we can verify of our multiplexer works perfectly according to truth table. Now let's see the waveform. Now we can see here is the test bench code and here is the design code. I will run it. Now here we can see the two select lines here, 1 and 0. Now, now when select lines equal to 0, 0, it selects input A0. And when the select lines select 0, 1, the input is B1, so output is 1. Now when the select line is 1, 0, it select input C0 and therefore output is also 0. Now at last, when the select line is 1, 1, it selects input D1, so output is also 1. So today I have described the circuit 4:1 MUX. Thank you.